Hi, we're going to talk about like platform boot time reduction enhancements. It's a joint talk with Sammy from Intel and myself, Vishal from Microsoft. Uh, we both like are play in the firmware space at our individual companies. So we're going to talk about the need for boot time optimizations. So the outline of the talk is like we're going to talk through what are the driving factors, why we think like boot time optimization is like super important, uh, why does it play a major role, where do we sit today in our current landscape, and what are the possible areas where we can of optimization, and then where do we need the help from the community as a whole for driving this effort. Boot time optimizations, right? Like, so what are the driving factors, right? Operational agility and workload redeployment, right? So we want to be able to bring like, new systems into the fleet, or like, new updates to the, in our environments quickly. So, and how do we do that? Like, we want boot time is super important for that. Availability, like as time progresses from 3 nines to 5 nines, and like, availability is becoming super critical. So we want to reduce the amount of time that the customers see, like interrupted service like downtimes. Serviceability, super important, right? Like continuous updates. Fleet hygiene is becoming super important, right? So we want to make sure like fleet is continuously updated, whether it's an enterprise or a data center fleet. Security, like when there are like zero-day attacks or like security vulnerabilities, we want to make sure they're updated, like we can update the fleet quickly. Historically, like live migration has been used as one of the techniques to update the systems. But the problem with live migration is like there's a long turnaround radius, like depending upon the size of the VMs in terms of memory and disk. There is variability, and there's so there is the SLAs can be impacted. So these are kind of the key driving factors of why we think boot time is important. Second topic is like why does boot time play a major role, right? Like why do we want to optimize it? So we want to make sure like we reduce the reprovisioning time and like and the refresh time in the fleet, right? So that is one aspect. Updates have been a tricky problem in large fleets because like people don't want downtime, so they defer the updates. But as time progresses, you're accumulating more and more risk. So if we had like a solution where you can quickly update the system, boot it quickly, then that kind of helps there. Uh, the availability and downtime is also important. Like SLAs are getting super important in the cloud environments as well as enterprise environments. We want guarantees that like we can guaranteed SLAs like 3 nines, 5 nines, like downtimes, like all that stuff is becoming super important. We've also talked about like runtime updates in the past, and like and we want like ability to continuously update the fleet. And like boot times become super important when you've got like update patterns that pause and resume things from memory. So these are kind of the major areas where boot time starts playing a very important role. I'm going to pass it over to Sammy to talk through the next few slides.
Thank you, Vishal. Um, let us kind of look at what is causing a problem or what potential optimizations we can do. Basically, if you look at it, it's one of the slides from 2018, I believe. We were talking about you need to do a runtime update of the firmwares. If you look at the landscape, we have a lot of firmwares sitting in the system, just not by us, right? It's a microcode or even devices have a firmware. Everything need to be updated. And also, we can keep seeing that sizes are increasing because you have a lot of additional microcontrollers getting added to the system. That is another factor, also adding a lot more wait times because you need to coordinate between the system firmware as well as the device firmwares. And also, if you traditionally look at it, right, it's booted with one processor, BSP, and it does most of the work. And there are some MP code sitting there, but most of the thing is done by the BSP. And basically, if you are really looking at the time, right, it's tens of seconds when you are doing or in minutes when you are doing a cold boot, and if you are doing warm boot, it's in the order of tens of seconds, right? So the thought behind like what we want to do to reduce boot time, especially if we are looking at a warm boot time, right? thinking is, first let us look at theoretically what is possible, right? What is possible is, what you are going to have is, you have a firmware access, you need to get the firmware loaded to run the firmware. Then after that, there is a lot of register accesses are going on. And if you are doing a serial access, every access costs time, read and costs the time, write costs the time. And also there are wait times because you have a lot of mailboxes that you need to communicate, or you need to wake up the devices, and you need to wait for the devices to be ready to move on to the next phase. And also there are a lot of computational things, like if you do SAW and other calculations, you end up using the cores to do the work. So basically, like theoretically, if you even parallelize some of those things, you can come up with a number. And after that, you can go back and look, what are we getting it today? There are a lot of driver wake up, timer, other calls going on in the whole stack. So it basically adds to your boot time. If we looked at some of the 2018, we demonstrated a fast boot around 10 seconds. And even you can optimize it much further, right? The thinking is, can you do a parallel init of sockets on the even sub-socket level or the device level, right? If you do a lot more parallelization, then you can able to reduce a lot of overhead that is sitting in your system firmware today, right? So we basically throw like a lot of different points to consider. But what we are really asking is, we need to let us put our infrastructure to allow, when you're writing the firmware, you can really like make use of those infrastructure to optimize your the whole init sequences. So basically, at the end, what we are really looking as a community here, right? As OCP community, we can first establish what is the boot time requirement for the OCP systems. You might have multiple different users, but unless we have a requirement, we are not able to move the needle to solve the problem, right? Once you're able to establish a requirement for both cold and warm, then you can create a guidelines. You need to meet certain guidelines in order to optimize the firmware. And also the other thing is, you need to have the framework to write your code in a parallel way so that you can really like reduce the boot time. Thank you.
Thank you.
And any questions we can take?